Okay, so we're going to begin by doing a review of square roots. So if we start with something like the square root of 25, we know that's 5 because 5 squared equals 25. Okay, same thing with square root of 100. Okay, that's 10 because 10 squared is 100. So when we take the square root or radical of a number, and we've also seen there's cube roots, fourth roots, etc., we're looking for a number that when you square it gives you what's inside of the radical, or called the radicand. Okay. What if we have something like square root of 200? Okay. Well, if you go to your calculator, square root of 200 is like 13 point something. Okay. It's not going to be a nice whole number like square root of 25, square root of 100. So what we do, we can use a trick here. We can take out a perfect square. We can say square root of 100 is square root of 100 times the square root of 2, because 200 is the same thing as 100 times 2, and we know square root of 100 is 10. Okay, square root of 2, we can't simplify, it's just a mess of a decimal, so we leave it like that. Okay, we take out the perfect square, which is the 100, and leave it in front, so it's multiplying the radical, in this case square root of 2. Okay, something like square root of 72. Well, we can say that's the same thing as square root of 36 times square root of 2, and we know square root of 36 is 6, and square root of 2 will just leave. Okay, and we're going to see this more in the examples. If you haven't seen this stuff yet, we're going to do more practice on it below. Okay, so next we're going to look at square roots with variables, with even exponents and with odd exponents. I don't know why the formatting got kind of messed up on this, but whatever. So to find the square root of x to the 24th, we're looking for some power of x that when we square it, we're going to get 24, okay? Well, we know if we take x to the 12th and we square that, okay, by the power of a product rule, power of a power rule, those exponents multiply, that's going to give us x to the 24th. So the square root of x to the 24th is x to the 12th, or x to the 12th times x to the 12th. We add the exponents, 12 and 12, 24, which is what we need. Okay, square root of y to the 100th. Is it y to the 10th? No, because y to the 10 times y to the 10th is y to the 20th. Okay, so what we're going to need here is y to the 50th. When we square that, that'll give us the y to the 100th. So that's going to be y to the 50th. Okay, square root of x to the 3rd. Well, there's no number that we can, there's no power of x that we can square to make, there's no whole number power that we can square to get an x to the 3rd. So what we're going to have to do, we're going to have to break this down as this is going to be the square root of x squared times the square root of x. And the square root of x squared is just x, because x times x makes x squared. Square root of x will leave. Okay, so this is kind of like what we did over here. So this is going to simplify to x times the square root of x. Okay, square root of y to the 9th. Well, it's not y to the 3rd, because y to the 3rd times y to the 3rd is only y to the 6th. What we're going to do, we're going to use the same trick that we used in the previous problem. We're going to say this is equal to the square root of y to the 8th, times the square root of y. Square root of y to the 8th is y to the 4th. And the square root of y we can't do anything with, so we'll leave it like that. Okay. Now, when we add in constants, so like this 20, well, we're going to write this as square root of 20. We can take out a square root of 4 times square root of 5. And then for the x to the 5th, I'm going to take out a square root of x to the 4th, because that's a perfect square, and then a square root of x, okay? My perfect squares here are the square root of 4 and the square root of x to the 4th. Square root of 4 is 2. Square root of x to the 4th is x squared. And this and this, I'm going to combine together into one radical, one square root, okay? Okay, for this, so the 36 is okay. I'm going to go square root of 36. I'm going to take out a perfect square. That's going to be your y to the 10th here. And then we need a square root of y. Okay? My perfect square is the square root of 36 and square root of y to the 10th, which makes 6 y to the 5th. And we'll leave the square root of y. Okay, for square root of 27, that's not a perfect square. We can take out a perfect square, 9. Square root of 9, square root 3. For the x to the 7th, we can take out an x to the 6th. That's our perfect square. And then we're left with a square root of x. Okay, so the perfect squares here are the 9 and the x to the 6. Square root of 9, 3. Square root of x to the 6th is x cubed. And the 3 and the x are going to go together in one radical. Okay. Last one, for the square root of 75, that is not a perfect square. So the perfect square I can take out is the 25. So we got square root of 25 times the square root of 3. Okay, for the y to the 15th, I can take out a y to the 14th. And then times the square root of y. Perfect squares here are the 25 and the y to the 14th. Square root of 25 is 5. Square root of y to the 14th is y to the 7th times the square root of 3y.